Okay, let's go about solving some of these inequalities. Here I have x plus 4 is greater than 3x plus 16. So my strategy is going to be similar if I was solving an equality. I want to get x by itself on one side of the inequality to express the solution set. So I want to take everything with an x and put it on one side, and everything without and put it on the other. This has an x, this has an x, this doesn't have an x, this doesn't have an x. So if I move all the x's to the left, what I want to do is subtract this 3x from the right to get the x's to the left, and this 4 I need to move to the other side, so I'm going to subtract 4 from both sides. Now on the left, I have negative 2x is bigger than 12. So now what I want to do is get rid of this negative 2. To do that, I want to divide both sides by negative 2. So I want to divide this side by negative 2 to get rid of that negative 2. But whatever I do to one side, I have to do the other. Since I'm dividing by a negative, I have to change the direction of this inequality in order to have an equivalent inequality. So on the left, I just have an x. On the right, I have 12 divided by negative 2, which is a negative. So I'll go through the 4 ways of expressing this. The first one is this inequality. X is less than negative 6. It's pretty clear what's happening there. I can also convert this to set notation. The set of x such that x is less than negative 6. The third thing I can do is a graph. So here's my number line. Here's 0, positive 6, negative 6. And I want everything that's less than negative 6. That's all this stuff. And I don't want to include the negative 6, so I can put a parentheses or an open circle here. Finally, the fourth way, I can do interval notation. Remember that there's a negative infinity out here and a positive infinity out here. So I'm going to start on the leftmost part of this interval. That's a negative infinity. Do I include the negative infinity? Never, because it won't be a solution. So I'm starting here from the left and going all the way to the right. And the bound on the right is negative 6. Do I include it? No. So I'm going to put a parenthesis here. These are 4 ways of expressing the same thing. For number 2, I have a compound inequality. I have both 4x plus 1 is greater than negative 2, and I want it to be true that 4x plus 1 is less than or equal to 17. Because there's an and between these, we are requiring both of these things to be true for something to be considered a solution. In order to make this compound statement true, I have to make the left side true and the right side true. So let's look at the stuff that makes the left side true. I have an inequality here, and I'm going to use the approach I did before. Everything with an x I want on one side, everything without I want on the other. So I'm going to subtract this 1 from both sides, and I'll get 4x is greater than negative 3. I'm going to divide both sides by this 4 to get rid of this 4. So this 4 cancels with this. I don't have to flip the signs because I'm dividing by a positive number. So on the left I get x, and on the right I have is negative 3/4. If I drew this, here's 0, here's negative 1, and right around here would be negative 3/4. And I want everything bigger than that. All of this to the right, and that will be this inequality. So I do need to exclude negative 3/4, so I'll use a little circle here. Now let's work on the right inequality, say this one here. So to solve this one, I'm going to subtract 1 from both sides, which gives me 4x is less than or equal to 16. I divide both sides by 4. To get that x by itself, I get x is less than or equal to 4. So this is going to look like here's 1, 2, 3, 4. Here's 4. I'm going to want everything smaller than or equal to that. X is smaller than or equal to 4. So I'm going to take all of this stuff here. And I want to include the 4 here. So I'm going to fill that one in. Because this is an and, I want the overlap. I want everything that is in both. So I look at this sort of darker region here in the middle, and I start from the left of the darker region. If If I want to write this in interval notation, it's going to be from -3/4, and I want to move up till 4. I'm not going to include the left, and I'm going to include the right because there's a hole here, and there's filled in point here. So this is the fourth way. This is the third way. If I want to do it the first way, which is with a compound inequality, it's going to be that x is less than or equal to 4, and it's bigger than -3/4. Combining this inequality and this inequality, x is bigger than this one and less than this one. Finally, in set builder notation, it's the set of x such that x is bigger than 3/4 and less than or equal to 4. Let's solve another one. Here we have an or separating our inequalities for this compound inequality. On the left, I have x plus 1 is greater than 4. To solve this, I'll subtract 1 from both sides, and I'll get x is bigger than 3. Or x plus 2 is less than or equal to 3. To solve this, I'll get a -2 on both sides to get the x by itself. And I have x is less than or equal to 1. I always like to draw a picture if I can. Here's 0, here's 1, and here is, we'll say 2, and here's 3. -1's over here. This first inequality here, x is bigger than 3. So everything above 3 I want, and I'm not including the 3. For this one here, I have x is less than or equal to 1. That's everything less than 1 or equal to, so I'll include the 1. In this case, we have an or, which means in order for this statement to be true, you just have to satisfy at least one of them. If I say it's raining or it's not, it doesn't have to both be raining and not raining to be true. I just need it to be raining or not raining. What I want then is both the red part and the blue part together. This is the third way of writing a solution. If I do the fourth way, which is interval notation, I start from the left, -infinity. So -infinity up to 1, including the 1. The right side would be 3 to infinity, not including infinity, not including the 3. And I want both of these things together. Everything in the red part is a solution, and everything in the blue part is a solution. So I want the union of these two things. The first way is to write a compound inequality. Here I would just write x is bigger than 3 or x is less than or equal to 1. And set builder notation would give me the set of x such that x is greater than 3 or x is less than or equal to 1. Here I have a compound inequality. This is 3x minus 1 is bigger than or equal to 0, and at the same time it's less than or equal to 10. Note this is the same as saying this. 3x minus 1 is bigger than 0, and 3x minus 1 is less than or equal to 10. So you can work this out the same way, but if you have a compound inequality like this, you can't work with the whole thing at once. Whatever I do to any part, I have to do to the other parts. So if I add 1 to get rid of this 1 so I can get x by itself in the middle, I need to add 1 to all three parts. This gives me 1 is less than or equal to 3x is less than or equal to 11. Then I want to divide this by a 3 to get rid of that 3 out in front. Whatever I do to one part, I have to do to all three parts. This cancels with this, and I get that x is bigger than or equal to 1/3, but less than or equal to 11/3. This would be the first way to write that. If I drew a picture, which is the third way, it would look like this. Here's 0, here's 1/3, and all the way over here would be 11/3. And I want everything in between, including the ends. So in interval notation, the fourth way, it would be from 1/3 inclusive to 11 thirds inclusive.